Hi friends, welcome to Python Learnings. Today we are going to learn regarding operators. What is an operator? It is a special symbol which is used to perform arithmetic and logical operations between one or more operands. Operands are the values or variables. Python provides different types of operators to manipulate variables and values. We have arithmetic operators, comparison or relational operators, assignment operators, logical operators, bitwise operators, membership operators, identity operators, and special operators. Let's start with one by one. What are arithmetic operations? These are used to perform mathematical operations such as addition, subtraction, multiplication, division, modulus, exponential or power, flow, and floor division. I have considered here a equals to 4 and b equals to 2. We all know these basic operations. Let's run this. So 4 plus 2 is 6, subtraction, multiplication, division. Modulus is nothing but the remainder of that a and b. So it is 0 here. So 4 divided by 2, it will be 0. The remainder is 0. So a power of b. So 4 power 2. 4 4s are 16. So that is the output for this. Floor division, 4 divided by 2 without the decimal value, that is the output of floor division. So these are arithmetic operators. And next is relational or comparison operators. These are used to compare the values of two operands and returns a Boolean result. So let's uncomment this. So these are just comparing between two operands. Let's run this. So I have committed here A and B. So uncomment this. Let's run this. So here 4 is equals to 2. It is comparing. So that is not true. So it is printing false. A is not equals to B. 4 is not equals to 2. So that is why it is true. So it compares like 4 is greater than 2, 4 is less than 2, 4 is greater than or equals to 2, and 4 is less than or equals to 2. So outputs for this. So let's comment this. Next, assignment operators. Assignment operators are used to assign values to variables. So I have considered here A as 4 and I am assigning A with B. I am assigning A to B. So if I run this, see here, A equals to 4. I am assigning that 4 to B. So I'm getting, when I print B, as 4. So here, A plus or equals to 5 means A equals to A plus 5. So A equals to A plus 5 is, in simply, we can write as A plus or equals to 5. This is equals to A equals to A plus 5. So similarly for this, A equals to A minus 5, A equals to A into 2, A equals to A divided by 2. Similarly, all these. So we have written simply. So here, so A equals to A plus 5. So A is already 4. 4 plus 5 is 9. So output is 9. So currently A is 9. So 9 minus 5 is 4. So A is 4. 4 into 2 is 8. So currently A is 8. So 8 divided by 2. That is 4. Now I have considered A equals to 8. So 8 modulus 3. Output will be 2. So A is 2 now. So 2 power 2. A equals to 4 now. 4 floor division 2. So A is 2 here. So these are assignment operators. Let's comment this. Next are logical operators. These are used to combine conditional statements. In logical operators, we have and, or, and not. So we have truth tables for these. For and, if both A and B are 1, 1, that is true, true, then the output will be 1, that is true. If A is 1 or B is 0, or if A is 0, B is 1, if both are zeros, then it will be zeros only in truth table of and. So both should be 1, then only it is 1, that is true. In OR table, if A or B, anything is 1, if A is 1, B is 1, or A is 0, B is 1, A is 1 or B is 0, then the output will be 1, that is true. If A is 0, B is 0, then only it is 0 in OR table. Not. If A is 1, then not of A is 0. If A is 0, not of A will be 1. So these are the truth tables of and or not. So here, let's uncomment this. So A equals to true. True means 1. B is false. False is 0. So A and B both should be 1. Then only it is true. So both are not 1, 1. So for this, we are getting output as false. So any 1 should be 1. So it is 1 here. So 1, 0, it is true. Not A. So it is true here. So not A will be false. That is the output here. So these are logical operators. Let's comment these as well. Next are bitwise operators. These are used to perform bit level operations. So we have bitwise and, or, XOR, not, left shift, and right shift. So I have considered here A equals to 6, B equals to 4. Here it will follow binary format. So 2 power 0 will be 1, 2 power 1 will be 2, 2 power 2 will be 4, 2 cube will be 8, 2 power 4 will be 16. Like that it will continue so on. So I have considered here only 4 bits. So A I have taken as 6. So I am writing in binary format, that is 0, 1, 1, 0. So what are the combinations we get by adding these values to 6? So 4 plus 2 is 6. So that's why we kept here 1, 1 in place of 4 and 2. So 0, 1, 1, 0. For B equals to 4, what are the combinations we will get 4? Only 4 is the value we can get 4. Another combinations we won't get 4. So 0, 1, 0, 0. So this is how we have to write in binary format. So here A and B. So I already said both should be 1, then only it is 1. So 0, 0, 0, 1, 0, 0, 1, 1, 1. So output is 1, 0, 0. That is 4. 4 is the output. For OR, any one should be 1, 0, 0, 0, 1, 0, 1, 1, 1, 1. So the output is 6. So XOR truth table is if A equals to 1 and B equals to 0, or A equals to 0 and B equals to 1. In these two combinations only, the output is 1. That is true. In other two combinations, the output will be 0. That is false. And here not, we have simple formula minus of A plus 1. So that will be the output. So I have considered A as 6. So minus of 6 plus 1, the output will be minus 7. Here it will consider 8 bits to convert, but we have formula also. So I am considering formula here. A left shift of 1. So here 1 I have given. So that many times only I have to shift. So here I have given 1. So I have to shift only 1. 1 bit. If I have given 2 here, then I have to shift 2 times. So here for 6, A left shift of 1. Here I need to shift this to here, this to here, this to here. So I'm shifting 0 to here, 1 to here, again 1 to this place, and 0 to next place. So I'm getting output as 1, 1, 0, 0. Similarly, right shift. I need to shift one place. So I'm considering A here. So A is 6. I'm shifting to one place. So this 0 will be here. This 1 will be coming to this place. This 1 will be moving to this place. So 0, 0, 1, 1. So let's run this. See here, 4 is the output. 6 is the output for XOR. So I set the combination 1, 0 or 0, 1. So 1, 0 is the combination. So 2 is the output. For not, I'm using formula. So -7. So 1, 1, 0, 0. 1, 1, 0, 0. So 1, 1 is here. So 8 plus 4 is 12. 0, 0, 1, 1. 0, 0, 1, 1. So 2 plus 1, 3. 3 is the output. This is all about bitwise operators. Let's comment this. Membership operators. These operators test for membership in a sequence such as strings, lists, or tuples. I have taken here lists. So I have considered list. So I'm given B equals to 2, C equals to 9. So I'm testing here whether this membership is present in this list sequence or not. So I'm checking here, 2 is present in this list or not, 9 is present in this list or not. So similarly, see, 2 is not present in this list or not, 9 is not present in this list or not. Let's run. So 2 is present in this list, true. 9 is not present, false. 2 is not in list, but it is present, so it is false. C is not in list, that is true. So we are getting true. This is about membership operators. Identity operators. These are used to compare the memory locations of two objects. So is will returns true if both variables points to the same object. If they are not pointing to the same object, then we are using is not. Let's uncomment this. So I have taken here 3 variables, A equals to 2, B equals to 2, C equals to 3. So it is checking here A is B. So A equals to 2, B equals to 2. So 2 is 2. Let's run. So 2 is 2. So it is printing true. 2 is 3 or not, it is checking. So that is false. We are getting false. So 2 is not 2. It is checking here, but that is false. So we are getting output as false. 2 is not 3. That is true. That's why we are getting output as true. So these are identity operators. Next, we have special operators. In these special operators, we have operator precedence. So operator precedence means it determines the order in which operations are performed. So here, precedence of operators will be given higher priority. So precedence operators, the order for these operators will be, brackets will be given highest priority, first priority. Second, power is given or exponentiation is given second priority. Division is given third priority. Multiplication is given fourth priority. Addition fifth and subtraction sixth. So based upon this order only, it will execute. So here we have addition and multiplication. So multiplication is given highest priority than addition, then that order will be the execution. So multiplication will be done first and then addition. So 1 into 2 will be 2. 2 plus 8 will be 10. The result will be 10. And next one is associativity. So associativity is nothing but when we have same operators. So then the execution, the order of execution will be from right to left. So first, right one, 2 power 1 will be 2. And then 8 power 2 will be 64. 8 8 is 64. So that is the output. So these are all about different types of operators in Python. Let's see you in another video. Thank you. Bye.